My name is Dr. Jim. Good afternoon, everyone. My name is Dr. Jim Lanny, and I'm really pleased to be able to show you and give you an overview of Intellectus statistics. Just as a brief background, Intellectus was developed because students and faculty came consistently for over a decade, and they had the same three problems. They didn't know what to do, what analysis. They didn't know how to navigate the tool to do that, and they didn't know how to interpret the output. So I will give you the 1-minute version of how we responded to those three repetitive questions, and then give you more of the 15-minute, how do I go through step by step, and then leave plenty of time for Q&A and get everybody out underneath the hour. So again, if you want, you can ask questions at any time. Ashley and Melissa will answer those the best we can. And let's get into it. So the three broad questions: what do I do? How do I do it? And what does it mean? So we have a decision tree which has layperson's questions. So I want to predict an outcome that's scale. Well, I'm doing a linear regression. So the decision tree helps you figure out what test to use. Then I can go to conduct the test and I'm right in it. And then I can just put in my variables, achievement post, put in my predictor variables, achievement pre. Okay. That's all there is to the conducting of it. Okay. Put the variables in. Okay. As you'll see, all the assumptions are built in. And you can see that this is in English. So let me just walk through this real quick. So you can see the assumption is built in of normality. We have a helpful scroll over to see whether it looks more normal or not. Did it with homoscedasticity. We have a nice scroll over to see what looks more homo or heteroscedatic. Outlier analysis. So in terms of using the tool, we just married the assumptions with the test and then presented the best way we could of what that is. And then we have the results. So one thing to notice is that things are in APA 7, so that's great. You're not fussing with tables. And here we can see that the achievement pre is a significant predictor of achievement post. And this is a sample of the write-up. The results of the model were significant, okay? Indicating that 61% of the reasons, basically, all the reasons why achievement post varies, about 61% of those reasons can be accounted for by achievement pre. And when we do have a significant predictor, as we do here, we then interpret that beta coefficient. So again, one thing is, well, how do I explain this? Well, here's the interpretation of that beta coefficient. That on average, when I increase achievement pre by 1 unit, achievement post will increase by almost 1 unit or 0.99 units. And then it all downloads into an editable Word document. So if you have clean data, the benefit is that you can probably get a draft of your results in under a minute. I've helped folks with their DMP projects, in 41 seconds. The data cleaning is the problem. So to address that, we do have a data cleaning wizard, and let's just get into that. So I'll start here. Well, it's web-based, and hopefully folks are logged in or can follow along. And projects is where we get the data in. And I can upload data manually by start typing or paste in a flat file. I can choose an example data set, and there's lots of them. And I can upload data. So I will upload a data file, which is called the Rosenberg Self-Esteem Scale, and upload the file. Okay, so it immediately dumps you into the data cleaning wizard. And what is that going to do? So I should show you what that data cleaning wizard what the initial file looks like before we get started here. So this is a very typical file from like downloaded from Qualtrics or something. You have questions, names, shorthand names of the questions or variables here. Okay. You have a second row of headers with the actual question, and then maybe a scoring sheet or a coding underneath. So we clean this up in several ways. For example, we will get rid of the multiple headers, we'll update the variable names, fix misspellings, convert Likert to numeric values. Oftentimes you have a 7-point Likert scale from strongly disagree to strongly agree, but when we add those, we need to put those all into numbers. Okay, so let's get them into numbers and then create those subscales that we need and then add an ID variable. So let me show you how that is done. So here, we don't need 3 rows of headers, so I'm going to get rid of the headers here. Okay, all right. So I'm going to apply those changes. So it gets rid of those headers and just go to next. Here I can edit variable names. So here I could have, age. Okay. Here I can have, sex. And then I'll leave these other variables as they are. Okay. Okay. Apply the changes and then go to next. Okay. So here, now I'm going to start drilling into misspellings. So when we conduct descriptives, I don't want disagree with 3 E's to be a different level or label than disagree with 2 E's. So I can merge those, and you can see the levels before the merge and the levels after. So that disagree with 3 E's is gone, so I can apply those changes. Ditto with K post 4. Okay, again, merge those. So that just cleans up some of the levels. Okay, great. Do I have Likert type scales in my data? Yes, I do. Well, what kind do I have? Well, we have lots of options, but mine happens to be a 5-point agreement scale. So, and it looks like this, okay? And I want to turn it into numbers, okay? So, and I want all of these variables, K1 pre, 2, 3, 4 pre, and then post 1 through 4. I want those all changed from those labels to numbers. Great, apply those changes. And that did that, and then I can go to next. Now, do I have subscales? Well, yes, I do. So my first subscale I'll call pretest, okay? And let's just say that I want to average them. And I have these pretests here. If I had a reverse coded item, okay, I'll put that in here. So I can just put in the values 1 to 5. So sometimes questions are asked in the reversed, right? So if I'm asking about knowledge, do you know this? Do you know this? Hey, how little do you know about this? Or things of that sort. A question just asked in reverse. So you can reverse code right in the same shot there, okay? And apply changes. Okay, so I'm naming the subscale, I'm selecting how I want it, and then I'm endorsing which items I want to be part of that, and reverse code, apply changes. Add another subscale, sure, I have a post test. Okay. I'm also going to average that, and it's these guys here. And my third one is reverse coded, let's just say. Okay, oopsie. So, and you can see that pretest is a new variable there. So apply the changes. Great. No more subscales, go to next. We suggest adding an ID variable, so I know I have 10 folks. And finish. So what I have is my data set moving down the road of getting cleaned up. I have an ID variable. Age, I might want to say, well, that's really ordinal. So there's a little bit more data cleaning. And I can say this is, 20 to 29. just type right in at 30 to 39, 40 to 49, oopsie, and 50 plus. 50 plus. Okay, so, and just put that right back in there. So I can do some of that, a little additional data management, my ID, my age, sex, and then here are my questions, K1 to 4 at pre, K1 to 4 at post. I also had a variable around leadership, open-ended questions about their thoughts about different aspects, and then my new subscales here, okay? All righty, I want to just do one quick thing, just to kind of make it more interesting. I'll just change some of these, okay? Just for the heck of it. Okay, so hopefully 9. Oopsie. Okay, so let me just hit save there. So just to see if we can see some differences. Actually, let me do one other quick thing. Make these low. Okay, so okay, 1 low, 2, 1. Okay, so mock data set. Okay. Here's our data. And once we finish that data cleaning, we are in data management. So this is a very sequential process. And I can do things like do the variable calculator here, okay, if I didn't do it during the data cleaning wizard. And I can do other data management tasks, but the important ones are probably the variable calculator, perhaps getting rid of univariate outliers. Let's see if there are any. We can check all. Not the ID, but let's just see if there's any univariate outliers. Okay, and then I'll append new variables. So here's the new variables with outliers. They're all still there, so there was no outliers there. So you can do different data management tasks. You can download your data. One thing that one quick AI feature is sometimes you have a quantitative data set, but you've asked an open-ended question, as is here, hey, what do you think about leadership qualities? And they've given some responses here, but we have a text classification that I can put in that open-ended responses, and the AI will now bucket those items. And if I run descriptives on those buckets, I no longer have, that is leadership nominal. I no longer have, 20 separate responses, but now I have, 4 different kinds of buckets: transformational leadership, organizational value and culture, soft skills, strategic thinking. Now I can use that new variable called leadership nominal to interact with other variables like sex or age or even scores. So that's kind of a cool, quick AI feature for, it's not a full-on thematic analysis, but it's moving you in that direction. Okay, let's go down to plots. We have 10 typical plots. I'll share, let me just go to pre-test versus post-test. Okay, maybe I want to group it by, age. Okay. Simple scatter plot. With so few people, it's not the best looking scatter plot in the world. But that's the pre and post, and those are the data points in that plot. You can see that we automatically run a correlation between pre-test and post-test, which is not significant. Okay, and then there's a correlation for each of the different levels. And you can drill into these things and, so forth. You can export these things in numerous ways. And all of these things are pretty simple. Let's run one other pre-test. pre-test, post-test, by age. Just a different way of looking at some of the data. So again, you can scroll over to see what the pre-test for each age group was and what their post-test scores were. It's a nice plot to kind of get an idea of what's happening here, which is that I put these things in reverse, but that post-test scores were higher than pre-test scores, and most dramatically for the blue, which is the younger group, 20 to 29. Okay. Let's go on to analyses. We've done one descriptive on the bucketed open-ended question, but I've said it once, I'll say it again. Always run descriptives on your data of interest. Okay, so age, sex, pre and post. The reason you do that is, let me just run that real quick. So I just selected descriptives, put in the variables, and this is the output, which is APA 7 tables. You can, and then you have a little write-up. It's kind of AI-ish that, what's inside of that table. Well, the most frequently observed category of age was 50 plus, which accounts for 35%, males and females, the split. And then for the scale variables, we have means, standard deviations, give helpful scrollovers. Okay. All right. And so you want to run descriptives because, data entry errors happen that I could have put in a 55 instead of a 5, for example. So you want to just kind of glance at that to make sure, okay, everything seems cool with my data. There's no obvious data entry errors. Ranges from 1 to 5 makes sense. 20 folks in here makes sense. And then we can kind of move along. Okay, other things that we want to do. I mean, we can do correlations. Just put in pre-1 and post-1, for example. If I can find post-1, there we are. So we can do simple correlations. For all of these tests, the assumptions are built in. You can see that's the plot, not the prettiest plot in the world. Here, we can see the result of that correlation. So we just presented these APA tables in 2 different formats. This might be the most appropriate, or really, if it was one correlation, perhaps no table at all. But the results of the correlation, there was significant positive correlation between K1 pre and K post 1, 0.94, indicating a large effect size. And here's the interpretation. As K1 pre increases, K post 1 tends to increase. Okay, we can also do things like t-tests, pair t-tests. Again, select let me show you 2 things here. One is you can scroll over even before you click on it to kind of say, okay, test the mean difference between 2 scale variables. Okay, that seems about right. I can put in my variables, pre-test and post-test. Helpful icons ensure that the right level of measurement variable is included. We'll also note on most of these dialog boxes, a video tutorial, like a 3-minute kind of how-to is there. And so pick the test, put in the variables, and hit calculate. And here, the assumptions are built in again. So let me give 2 use cases. One is in teaching, and one is in conducting analyses. In the research mode, you have a draft of your results. Normality was assessed with the Shapiro-Wilk. It was conducted and interpreted. A significant Shapiro-Wilk indicates that that assumption is violated. Here's the results of the t-test, was significant. And here's the interpretation that the pre-test was lower than the post-test. We can see those means of the pre and post and the figure and the APA table with the effect size. So for those doing research, faculty or students, you have a draft of your results very, very quickly. And you're not fussing with tables, and you have helpful scrollovers. We also, once a quantitative assumption is violated, as was the case here, well, we've enabled the non-parametric equivalent test, which is the Wilcoxon sign rank test, which basically looks at pre and post or matched pairs without the assumption. Here we could also see there was significance, and the medians are different from pre to post and helpful scroll over. Okay, of that box plot. So by identifying the test, we kind of quickly have a draft and a picture of what that data is saying. Yeah, normality was not met, probably because there was too few observations. And nevertheless, the paired t-test was significant, the Wilcoxon was significant, and we're kind of saying, hey, guess what? This pre and post is different. These pre and post are different. So that's the picture that we're coming to. And then we can download that document, that editable Word document. So here are the things that were done. Okay. Here are the results. Okay. My descriptives, my correlation, my correlation results, and my paired t-test. And Wilcoxon. We've also included APA style references for all the in-text citations. And we've also included a glossary of terms and symbols for the different tests that were conducted as well. So that's the quick snapshot of this. Know that we have lots of different tests. There's 60 different tests, but probably more. If you start, you could add several IVs here and so forth. So, 50 to 60 different tests, t-tests, all the MANOVAs, most of the regressions, chi-squares and non-parametrics, structural equation modeling and path analysis, mediation, moderation, and other types of sophisticated tests that typically depend upon other experience with other tests first. Okay, so I talked about getting a draft for research. Let me also say that there's a use case for teaching it. So that use case is, for example, is sharing with students or showing students, hey, what is a paired t-test? Well, it's got this assumption, it's got this kind of tables, this kind of figure. Great. I can then use, if I was a teacher, use different data sets to load up. So I have data at my hand, okay? And I can go to the the raw output, and have students write up sample 1, sample 2, sample 3. After they see how it's written up, and after they practice a few times, they'll have a good handle of it. I mean, I think one thing that's, I'll say too common, which is the leaky vessel syndrome. Students come in, they learn a t-test, they pass the class, they get the A or the B. By the time they get to their research, they're at ground zero. They don't know anything. So hopefully this practice and an easy to use tool is helpful in really getting that concepts to them. So using the interpreted output, the raw output, and the example data sets, and know that we have 60 lessons that you can curate. That's to say, well, I want to teach independent t-tests and paired t-tests, but not one sample. You can put together and very easily select the course that you want to teach to your students based on their experience and so forth. These all go behind your learning management system. They're really dirt cheap. It's something of the order of $8 for a whole year, more than the tool. So it's really, really inexpensive. As I say, the grades go to your grade book, goes behind your LMS, and we give you tons of support around the course as well as the tool. The other thing I'll mention with regard to collaborative research or with teaching is that we have a nice feature called the share feature. So the share feature, really you put in a colleague or faculty or student's email address, click share, and that whole project goes to those recipients. Well, what's included in a project? Okay, I mean, before we're kind of an email, I'm sending syntax files and data files and Word documents. Here, all the notes are built in. I could have global notes. The data is part of that project. The plots are part of that project. The analyses are part of that project. And any analysis related note is part of that project. So all 5 of those things get sent to those recipients, and you can work on it in a kind of a serial fashion, duplicate the project and so forth. All right, I'll say just a few more things and then I'll open up for questions. So we've looked at the the decision tree to figure out what test to use. We also have data plans built in. This is helpful when you're applying IRB or you need to write a methodology section. Well, how do I write up a paired t-test data plan? Well, this is one draft of that. How do I address the sample size? Well, you can click on power analysis, and for different effect sizes, you can quickly see what the desired sample size is. These are all downloadable, editable documents. Okay. For students that need more hand-holding, we have built-in consulting sessions. We do have a fee associated with that, but you can share your project and really figure out, am I doing the right test? Is my data set up correct? And do I understand that output? So it's pretty reasonable. And there's other kinds of things like how-to videos that are built in that are bucketed by different topics. You know, how do I conduct a t-test? Well, here's how do I conduct different t-tests. And I think with that, I think I'll just stop for a second. Okay, so can this be done in AMA style? We have, thought about that, and at the moment it's just an APA, but that Word document is editable. So that's what's happening here. Thanks for the presentation. You're welcome. How does numeric data and SPSS correspond? Right. So in SPSS, there's a code book. What does that mean? Well, kind of like we had numbers, 1 to 4 for the age. Well, or 1 for male and 2 for female. We avoid that whole step. Just if it's a ordinal or nominal variable, just put that label in there and we're done. If it's numeric, put that number in, we're done. So there's no going back and forth between that. So we just stop that process because it's unnecessary. Okay, other questions as we're going through that? Good question, that differentiation. Questions, or you can share your project. Happy to talk about that. Hey, Darren, thanks for joining. Happy with the AI example, open-ended responses. Yep. Are there any other AI features coming in the near future? Thank you for your question. So there's always a question about, I think there's a few that should be coming up. One is when I have a when I have a plot, I have the scroll over, but I would like AI to tell me, is that at the end of the day, is that more normal or not normal? Okay, or I don't know. So that's one thing. I think we are primed to have a summary of what's happening, summarize those significant results. So that's something that should be there. The scroll over for the plots. Um, and perhaps some integration between a qual and quant tool. So those would be the three things that I'd want to be focusing on in the future.
And I think if there's suggestions on how anyone would like us to incorporate AI, send them our way.
Love it. Love it. Okay, how do you create a variable from an existing variables? So we really just kind of did that, right? So when I did I uploaded K1 to 4 pre. So, so to create a new variable, I can go to management, it's a data management task, and I can do a few different things. So one is that variable calculator, right? I could have, total. I could just do a sum, right? Okay, so I can use the variable calculator, mean, or sum composite, submit. That's one way to create a new variable. I can also start binning that. Well, what does that mean? Well, binning is, well, I have this variable that goes from 17 to 21, but maybe I want it cut right down the middle, at 18 or some darn thing. So I can now have take a scale variable and categorize it into high and low, for example. Okay, I get add a new variable. And now I have a new variable called achieve pre-bin. I can then go into manage and just call this, 18 or less. Oops. Okay, or 19 plus. Okay, put that right into that same variable. So that's the second way to make new variables. If I remove outliers, um, it will create a new variable. Let's just try that. So let's just do two things. So one, let's just get rid of one variable there. And let's put in a crazy outlier here. All right. All right. So if I wanted to get rid of a univariate outlier on total, I think that's where I put it. Okay. So it created a new variable, total, without the outliers, and it got rid of that 1,000. Okay, so that's one way to do it. I could also impute data. So here I have a missing value. That's really helpful if you have, 10 items, but somebody missed one. I don't want to throw out that whole observation. And I can impute, achieve pre, okay, make a new variable. Okay. By the way, that other variable is about 19, so it's not perfect, but it does put in the mean plus or minus some standard deviation. So there's a few different ways of putting in variables there. Text classification, yeah. So that was really, that came out of what do folks do when you have a few open-ended questions? I have to go read through those 30 or 300 or however many I have, but a nice way to kind of start working with that, which is what we did here. If I just, right? So now I can start working with those buckets. Okay, other questions? All good questions? Things that you're struggling with. So it's an overview, but I'm here to help. So if you tell me what you're struggling with, maybe we can talk about that. Be it in the teaching realm or in the analysis realm or data management realm. You're welcome. All right. And we can break early, no problem there too. Let's see, go over some of the benefits of auto drafting, efficiency, accuracy. Okay, so, well, so this is right. So what's happening here? This is auto drafting the results of that correlation. I should say that a lot of this is templatized. So this statement right here is going to be published with Turnitin. So you really have to put these things into, say, ChatGPT to kind of put it in your own voice a bit. Can the text classification be used to turn a transcript into a quantitative data set? It's really not designed for that. I mean, maybe I'll just give a quick plug to the qualitative. Somebody knows someone doing qualitative. Really, in this particular case, you know, you can really, let me see what I have here. No transcripts, of course not. So, digestive disorders. So here, you know, I've loaded up, you know, entire transcripts, and then we're able to, you know, auto code. That is, they find the patterns, name that pattern with a code name and description, auto thematize, finding the proper number of code with the proper number of themes rather, and then tying your research question to a particular theme and the rationale for that. So we do have, Melissa, maybe you can share when the other quantitative workshop is happening and the qualitative workshop and qualitative overview session. So if you can put that information into the chat or into the Q&A.
I will, it's a lot of information, so I'll send the email of the recording and everybody will get all those links.
Awesome, awesome, thank you. What's the difference between different types of correlations and what are they indicators of? So, so different correlations, these Pearson is a typical correlation. It's a scale variable, has an assumption of linearity. You can't have curvilinear things going on. These other ones, if you scroll over, it really can take, you know, ordinal variables as well as scale variables. The partial correlation is looking at two variables, but one to control for yet a third variable. And a point biserial correlation, let me just run it. So is really looking at a binary variable with a scale variable. So let's see if I have a binary variable, great. And a scale variable, let's just say pre-test, post-test. So we're correlating sex with pre or post tests. And here are the results. Very large correlations. That's a moderate size correlation. Happens to be not significant in a small sample. If it was significant, let's just see if we can make it significant really quick. Let's just do this one. Let's just do since we're messing with this. And since this is all mock data, let's just call this okay. So let's correlate now K1 pre with sex, just to show you what a significant correlation looks like. Significant point biserial correlation, I should say. So under correlations, point biserial, sex is one variable, K1 pre is the other variable. So here it is significant. So it has a typical correlation right up, but the interpretation sometimes is tricky. So this suggests that moving from the male category to the female category is associated with a decrease in K1 scores. So that's one interpretation of that. Female category of sex tends to be associated with lower K1. So, but basically scale variables, Pearson, ordinal variables, Spearman, control for variable, partial, and binary plus scale. Purpose here is a great way to improve item performance on test surveys. I am happy to have guest speakers here. So we should explore that. Because I typically do my normal presentation, but I am happy to bring in others. And Melissa, I think that's a great idea, not only from Darren, but for others to bring in their expertise and different use cases. So I'd like to, learn more about that. Other questions? We're about 15 minutes left, but happy to go over anything.
And if you don't have questions right now, like I said, I'm gonna email the recording. You'll have our contact information. You can reach out with any questions that you have.
And my request is please tell others, tell other students, tell other faculty. There are people struggling with SPSS or Excel or Stata that says, I need an easy way to get a draft of my results or to teach my students. So please do pass it along. Happy to give personalized demos and trials and so forth. So whatever you can do to spread the love, we appreciate that very much. And we'll give a few more minutes and we'll get the recording to everyone. And you can share that as well. And if there's no more questions, I want to thank everyone for taking time to learn and ask great questions and have great ideas, and look forward to seeing you at a qual workshop or overview or of the quant workshop. So thank you all so much.